Hello, my beautiful math mavens, and welcome to another episode of Fun Times in Statistics. I, as always, will be your host. I apologize for the fact that my voice sounds a little raspy today. It's a little dry in the hotel I'm in. Not that you need to know that. So these are the example videos for Chapter 7, and you'll see that I have four of them, and I've broken this video into four parts just to make it a little bit easier on your viewing. If you've already read through this document that's at the top of these videos, you'll notice that I've got it kind of in order here. So I've got my means first, since this is quantitative data for my first two. And then I've got my population proportion questions, or my stuff that's categorical data, in the last two. So if you know that you need an example with some proportions in it, you might want to skip this video because I'm going to start with number one. So we're going to start with considering this population. And I know it's a very small population, but we're going to pretend it's a population for today. So I'm going to go into Minitab here. It's asking me to calculate in part A the mean of the population. So just as a reminder, how you calculate a mean in Minitab is you just go up to Stat, Basic Statistics, Display Descriptive Statistics, throw your variable in there. I'm going to hit the Statistics button. And then I don't need any of these extra that's easier just to hit none and then select mean, because the only thing I need is the mean here. So I'm going to hit OK, hit OK again, and there is my population mean. So I'm going to copy that over. Oh, why am I copying this over? I might as well just type it. It's not like a short. It's long. The mean is 12. Done. Now this next part is a little bit more difficult. So what I want to do is I want to pretend we're going to do a sampling distribution. So I want to create all samples of the same size so I can make their distribution and stuff. So I'm going to make a little bit more space here and then use a tree diagram to do this. Why do I not have the drawing one? Oh, it's under developer. Pens. There it is. Okay, so I am going to use my pens and draw myself a tree diagram. So there's three choices. Oh, this isn't working so well. Hold on a second. I'm gonna have to cut this part of the video. Tree diagram. Yep, it's not recognizing my pen. Alright, I'm gonna have to draw it with a mouse. That should be sufficiently terrible where you guys all hate this. So when I go to select my first item from my three-person sample, I have three choices, 6, 9, and 21. And then when I go to select my second item, there are three choices as well. This is just a nice way to keep track and then make sure you don't miss anybody's possibilities. So I'm going to try to keep these in the same order. 6, 9, 21, 6, 9. Oops. Did I just hit undo? Yeah, there we go. Nope. Lost the pen again. 9, 21, 6, 9, 21. Okay. So I notice from this I can go down each path and get all my samples. So I'm going to take the liberty of typing those into Minitab because I'm going to make Minitab do all my means at once. Hope you're ready for this. If not, oh boy. So we're going to list all the possible ones by just going. Some days I love the drawing aspects of this, sometimes I do not. So if we just list all these going from top to bottom, there's 6, 6. I'm just going to put some spaces. 6, 9. So I'm just going down all the paths. 6, 6, 6, 9, 21. So now I got to do all the 9 ones. 9, 6, 9, 9, 9, 21. Alright, last but not leastly, 21, 6, 21, 9, 21, 21. So there's all of my samples. And it appears there are, 9 of them, rather ironically. So like I said, I'm going to put them all in Minitab so I can calculate the sampling error associated with each sample mean. So I'm going to calculate all their means and then subtract the actual mean, that 12 from them, and figure out what that's going to be. Got it? So, because I'm lazy, I'm going to make Minitab do this for me. You could do this by hand with such a small sample, but, I got time, right? I don't have to be downstairs for another hour to hang out with other people who like teaching. So that seems reasonable. So this is going to be 21, 21, 6, 9, 21. And the order I put it into was on purpose so that, like, this is going to be my smallest samples average, and this is going to be the largest, and clearly you can see what they're going to be. But here we go. So we're going to go to stat, basic statistics, display descriptives, and I just need my means for these guys, so you can highlight and then hit select. When you see this dash show up, that means it's going to do all of them from here to here. And we hit OK. And here's all my means, and I like this because it's going to do it as a table. So I'm going to copy this over for my part C. Boonk. Aw, I was really hoping that was going to fit on one page. I'll just make it so you can see it all. Okay, so then to calculate my sampling error, I just need to subtract 12 from all of these. So I'm going to create a new column. Layout. Insert right. Oh, that column has nothing in it. Why does it look like that? Can I make it look bigger? I swear, half of these videos is just me messing with Word trying to get it to not hate me. Oh, why is it so small? There we go. Hopefully I can cut that out and so you guys won't hate me. So we're going to do, sample mean, which is your X bar, the things we just calculated, minus the population mean, which is the 12 we calculated earlier. So I'm going to make this big enough to where you can see all of it. And remember, this one isn't just a mean, it's a sample mean, because they were obtained from the little samples of size 2. So going down here into this first box, 6 minus 12 would give me negative 6. 7.5 minus 12 would give me negative 5.5. I'm really challenging my mental math here today. Oh, I don't want to do this one. 13.5 minus 12. Aren't you glad I did this one instead of you? So, oh, in this case I finally hit one that's bigger. Okay, so that's going to be 1.5, and that one's positive, not fraction, 0.5. Sorry about that. Another 7.5 minus 12. I'm not trusting my mental math on that one for some reason. I think it's because it's so early in the morning when I'm recording this. Hello. Oh, you guys can't see the time on this video. It's like 5 a.m. I couldn't sleep, so I just gave up and got up. Yeah, I didn't trust my math, and I shouldn't have. Ugh. Well, that's a sad sight. That's what I get for doing this too early, right? Blame myself. Why is it music? Let me look at my history, make sure I've typed that in right. See, I'm not trusting myself at all. Where's the trust? Well, hopefully it will be taken care of by my tools. I love how Minitab decided this one needs 3,000 zeros after it. What is with that Minitab? Ay, ay, ay. So that one has a sample error of negative 3. Oh, that's right, because that's going to be a smaller one. Okay. 15 minus 12 will give me a 3. Hopefully, if anything, this question will teach you, oh yeah, sampling error isn't that hard. I just have to have a sample, find its mean, and then compare it to the sample itself. Ooh, 1.5. I keep on typing 3. I need to change the lighting on my keyboard. It's too dark. 15 minus 12. Boy, this is the least interesting thing I've ever done with you. 21 minus 12. So that should be a 9. And we'll double check that last one just because I haven't had one that big yet. Yeah, alright, good. Cool. So if you wanted to describe this overall, you could say my range of sampling errors is, let's see, what's the lowest it is? Negative 4.5, the one I screwed up originally, to, what's the biggest one? 9. Alright. Even with a sample size 2, there's quite a bit of room for error, and quite a bit of variation in the possibilities. So we're going to assume each of these is equally likely, and then produce the distribution of sampling errors. So in order to do that, I'm going to actually type them into Minitab and let it make the histogram for me, because that's what a distribution looks like. If you want, you can also do a table for this one. I'm going to do that as well, because that's what a distribution is. It needs to describe the values and how often they occur. So I'm going to write this as sample error, so that I know what it is. So let's type them all in. Negative 6. Oh, I immediately screwed up here. Negative 6 to 9. negative 4.5, 1.5, negative 4.5, negative 3. Oop, I am so sorry, Minitab. I thought I hit enter in between those. 3, 1.5, and another 3, and then a 9. So let's see, I have 9 of these. Are there 9? Oh yeah, because there's 3 groups of 3. Okay, so now let's let Minitab go ahead and do this. So what I'm going to do actually first is do a table. So if we go to Stat, Tables, and then Tally Individual Variables, I'm going to throw a sampling error in there. So I'm creating a relative frequency table. I'm going to change this to percents. I don't want counts because we use frequency to represent our distributions. And then hit OK. It'll tally it for me. So this gives me a list of my values and how often they occur. And that's all I really need for a sampling distribution. Sorry, a distribution itself. So if you don't like that and you like visuals better, you want to do a histogram. So when I go to graph, histogram, I'm just going to use a simple because it's only one variable. There's no point in using any of the others. Let's throw a sampling error in there. I'll wait and see how it looks before I hit any options. Let's hit OK. I mean, let's see if what happens if I make more bins here. Let's increase it to like 10 and see if that looks a little better. Either way, it's okay. It's interesting. I wish I could make it like, I don't know. I'm a little apprehensive with using this many bars just because the highest they get is 2 for frequency. So that's an okay histogram. We'll copy it and paste it into our graph. Normally I would play with this a little bit more before I'm decisive about it, but if you're looking to just show what the data looks like, the table's a little bit more informative for this, I think, than looking at the histogram. Okay, so that's it for video 1. Just to recap what we've done, we've practiced getting all the possible samples, doing their means. Woohoo, thanks Minitab. And then going through and calculating all of our sampling errors. Remember, error is just the sample population mean minus the population mean. And same thing for proportions. It's always sample minus population. And if you have a hard time remembering that, it's like the numerator of the z-score. It's always value minus the actual population mean. So hopefully that helps you. And I will see you in the next one.